Hello and welcome to another episode of STEM with Mr. N, where every week I'll be performing different demonstrations and explaining the science behind what we're seeing. This week we're going to take a look at surface tension. Let's check it out. What is surface tension? Well, surface tension is an effect where the surface of a liquid is strong. This happens because the molecules, the things that make up the liquid, are all pulling on each other. But the molecules at the surface of the liquid don't have any molecules above them to pull on. So they pull stronger on the molecules next to them and the molecules underneath. Surface tension is what also makes water droplets form into balls. Look at the water droplets being dropped on this penny. You'll notice that each droplet comes out as a ball, and when it adds to the water that's on the penny, it still has that dome shape. That's something you could try at home and see how many water droplets you can add to the top of a penny. This week, our experiments are going to be focusing on surface tension and the properties of water, as well as looking at how some animals use surface tension to survive. For our first experiment, we're going to look at how surface tension can allow heavier objects to float on top of the water. I've got a paperclip here, and if I put the paperclip into the bowl of water, you'll see that it just falls straight down to the bottom. What I'm going to do this time is gently lower the paperclip into the water and see if I can get it to float on that surface tension. You'll see now that the paperclip is using that surface tension to float on the top. What I'm now going to do though is try and break the surface tension of the water and see what happens to the paperclip. Soap molecules have two ends, one of which attracts water and the other end repels water. It pushes it away. Now when there's no grease present, the end that repels the water is the end that's active. So by using the cotton bud with a bit of soap and putting it next to the paperclip, I was able to break the surface tension of the water. Our next experiment, we're going to explore what's actually happening to the water though when its tension gets broken. You may have seen this next experiment recently. It's used a lot as an example of why it's important to use soap when you wash your hands. In the bowl of water, we have some pepper floating on the top, and like I did with the paperclip, I'm going to break the surface tension of the water using a cotton bud and some soap, and we'll see what happens. So you'll have noticed there that the pepper seems to run away from where the soap is. It's not that the pepper is trying to get away from the soap, but it's because we've broken the tension on the surface of the water. Now remember I said that surface tension makes water droplets form a ball. Well, it's the same in the bowl of water here. The water will have a bit of a bulge to it. But when you break the tension using the soap, that bulge drops and the water flattens out. And as the water moves to flatten out, it takes the pepper with it. There are some animals which rely on surface tension to be able to survive. Water striders and fishing spiders are two examples of these. Both of these creatures have small hairs on their feet and legs which repel water, and they travel on water similar to how you would jump on a trampoline. As they press on the water pushes back against their foot, allowing them to skip across the top of the water. There are larger animals which also rely on surface tension, such as the basilisk lizard and the western grebe. Now both of these animals use a different technique, and they slap the water very quickly with their feet. The surface tension pushes back against this slapping, and that's what allows them to travel across water. Now although surface tension can be good for some animals, it can be deadly for other animals. With us, if we get dirty, we go for a shower, we take a bath, and when you get out you still have water droplets on you, which you can use a towel to get rid of, or wait for the water to evaporate. However, if a ladybird gets some water on it, it has a really hard time shaking off the water droplet due to the surface tension. And it is even worse for an ant. Ants can find themselves entirely encased within a water droplet and are too small and not strong enough to break the surface tension of the water droplet. So though it can be good for some animals, it can also be deadly for others. One of the properties of water which allow it to have a strong surface tension is that water molecules are cohesive. This means they form strong bonds with each other. To demonstrate this, I have a glass of water and an empty glass. We're going to pour the water from this glass down the string into the empty glass, and we'll see what happens to the water. And what you'll notice is the water is running along the underside of the string rather than dripping out the glass onto the counter. This uses another one of water's properties, and that is the fact that water is adhesive, which means it sticks to other objects. Our next experiment is one of my favourite ones to demonstrate, and it's going to use the cohesive properties of water and the adhesive properties of water to do a bit of a science magic trick. For this experiment, I have a glass of water and I have a sheet of card, and as I said, it is one of my favourite ones to demonstrate. Now the water molecules are all cohesive, which I've said means they have strong bonds with each other. But water is also adhesive, which means it sticks to other things. The water in here is sticking to the card, and air pressure is pushing up on the card. If you want to know more about air pressure, check out last week's video where I did a range of air pressure experiments. There's always a risk with this one that you don't know how long the card is going to last, but it is a fun one to take some risks with. Our next experiment comes with a caution logo because it involves using a very hot pan. This experiment is going to demonstrate surface tension pulling water droplets into balls. What we're showing here is what's called the Leidenfrost Effect. Now, as I put the droplets of water into the very hot pan, the first bit of water which touches evaporates, but it creates some gas in between the bottom of the pan and the water droplet. That is what is allowing me to roll these water droplets around inside the pan. Our final experiment this week is one of my favourite experiments that I've discovered recently, and it involves using the surface tension not of water but of soap bubble liquid. I'm going to take my bubble wand and put a loop of thread just on top. I'm going to very gently poke a hole in the middle, and you'll see that now I have an inverted bubble. I have this hole here in a perfect circle. This is because when I've popped a hole through the middle, the surface tension of the bubble liquid is trying to pull itself away from where the hole is, and it pulls that bit of thread into a perfect circle. And because it is a liquid, I'm able to move that circle around, and the surface tension of the bubble liquid just changes as I move it from place to place. Well, that's all for this week's episode of STEM with Mr. N. I hope you've enjoyed it. If you have, like and subscribe and share the video around. As always, I would like to take this opportunity to answer any science questions that you may have about any science topics at all. So feel free to email me at stemwithmrn@outlook.com, and I'll get back to you with answers to your questions. Or I might even make a questions video if I get enough questions through. This has been STEM with Mr N, looking at surface tension.